The activation of the Lunar Gateway heralds a new era. A SpaceX Starship, having detached, makes its descent to the Moon. Meanwhile, a NASA Orion spacecraft has ferried 4 astronauts from Earth to this orbital station. 2 of these pioneers are now aboard the Starship HLS, ready to initiate the construction of humanity's first moon base. This marks the dawn of the lunar industrial age, characterized by innovations like lunar dust shields, habitats within lava tubes, light-bending towers, and a magnetic lunar railway. In a visionary move, human DNA is archived in lunar vaults as a safeguard against extinction. Orbiting cube satellites scan the lunar surface, searching for icy water deposits. On the ground, Viper rovers probe the South Pole, analyzing various ice types. Prime ice drills are deployed, extracting this vital resource to produce fuel, water, and oxygen. Concurrently, other rovers map the Moon's lava tubes using advanced 3D LiDAR technology. A groundbreaking experiment commences, blending lunar regolith with a plant-based adhesive to create a novel 3D printing material for construction. The first modules for habitation and life support, part of the Artemis program, are delivered to the Moon's South Pole. Back on Earth, an international treaty is ratified to protect lunar historical sites, including the Tranquility Base and the iconic first footprints, from being obliterated by dust from nearby landings. A pioneering electrodynamic dust shield undergoes testing. This technology, akin to the static that makes hair stick to a charged balloon, is designed to repel lunar dust, thereby safeguarding spacesuits, solar panels, and habitats. The cosmic Starlink network becomes operational, linking the Moon, the Gateway Station, Earth, and Mars. Construction of a new command and telecommunication center is underway. China and Russia commence the construction phase of their International Lunar Research Station, ILRS. Efforts to transform lunar regolith into fertile soil advance. At the Artemis base camp, a crew refuels an unmanned launch vehicle with Moon-manufactured propellant, testing the first lunar rocket, fuel-powered vehicle. The Russian and Chinese ILRS programs start building their lunar station. The Deep Space Transport Vessel, shuttling between lunar and Martian orbits, carries cargo and crew to Mars, with maintenance conducted in lunar orbit. Astronauts receive their first emergency warning of solar flares, allowing them time to take shelter within the habitats. The concept of lunar paraterraforming takes shape with the construction of the lunar world, a large transparent dome functioning as a greenhouse. Inside, houseplants recycle waste and convert CO2 into oxygen, while genetically modified crops, tailored for radiation resistance and low-gravity growth, also contribute to the 3D printing glue essential for construction. This marks a significant acceleration in lunar base expansion. The lunar bases, now including the ILRS and Artemis bases at the South Pole, witness participation from over 20 nations, ranging from India and Mexico to Australia and Germany. Above, 2 lunar space stations serve as transfer hubs, employing smaller shuttles for crew and cargo transport to the Moon's surface, bypassing the need for larger spacecraft with heat shields and air brakes for Earth re-entry. The ILRS evolves into a sizable settlement, with rovers patrolling and surveying the lunar landscape. It boasts capabilities in lunar-based astronomy, Earth observation, and biomedical research. Teams of scientists and explorers inhabit the Artemis base. Robotic rovers construct hobbit houses by layering hardened lunar soil over inflatable domes, offering protection against micrometeorites and radiation. Efforts are underway to erect the crater telescope, and a temporary shelter is established within a lava tube, naturally formed and ideal for temperature-stable protected shelters. The 2 primary bases, situated near the Shackleton crater at the South Pole, benefit from the Moon's rotation, 1 full rotation every 27.3 Earth days, with a lunar day lasting 29.5 Earth days. This unique positioning allows for consistent solar energy production, unlike other lunar regions that experience prolonged darkness. The pole's perpetual shadows in craters preserve icy water, crucial for life support and constant communication with Earth. Lunar facilities now refuel spacecraft en route to Mars from Earth and even host training centers for Martian astronauts. The inauguration of the Neil Armstrong Terra Solar Farm signifies a major milestone in the lunar industrial age. An unexpected discovery in a hydroponic greenhouse, an insect, origin unknown, suggests that life finds a way to thrive in the most unexpected places. University students start embarking on funded research missions to the Moon. Swarm robotics, consisting of tiny solar-paneled micro-rovers, are deployed for setting up temporary mining outposts. SpaceX delivers the first tunnel boring machine, repurposing lava tubes into permanent habitats and structures. The lunar mining boom begins, with nations establishing territorial zones and mining for resources like aluminum, titanium, and rare earth metals, including neodymium and lanthanum. The race for helium-3, a non-radioactive element ideal for fusion power reactors on Earth and the Moon, intensifies. As asteroid mining tests commence to redirect asteroids into lunar orbit, tensions escalate due to the unregulated, winner-takes-all approach to lunar mining. The Lunar Crater Telescope, a kilometer-wide facility on the Moon's dark side, begins operations, shielded from Earth's electrical and solar radio noise, probing the cosmos and the early universe. A UN treaty limits mining on the Moon's dark side, preserving it for deep space observation. Meanwhile, lunar job opportunities emerge on Earth, seeking a diverse workforce for the Moon. A unique space creole develops, blending various Earth cultures and languages, symbolizing the first off-world space-based culture. Innovative light-bending towers on the Moon redirect sunlight into dark craters, powering remote outposts in areas devoid of sunlight for millennia. The Lunar Rocket Factory begins 3D printing rockets entirely on the Moon, using materials from the Moon and redirected asteroids. Humanity's lunar outpost transitions into a self-sustaining colony, with automated facilities, para-terraforming domes, nuclear fusion plants, mining robots, and asteroid material access. This shift from the industrial to the information age on the Moon focuses on tourism, astronomical research, scientific exploration, and further space exploration. The Earth Defense Network (EDN) project is initiated, aiming to create an autonomous detection and early warning system with satellites equipped with advanced sensors and rail blasters, capable of disintegrating potential threats in space. The lunar landscape transforms with orbiting asteroids, space station factories, and an expanding magnetic lunar railroad. The mining of neodymium, crucial for supermagnets on Earth, becomes even more valuable on the Moon. The operational Lunar Laser Station now powers solar sail spacecraft, propelling them through space. Efforts begin to use asteroids in lunar orbit as platforms for constructing space elevators, potentially eliminating the need for chemical rockets. The Darkside Deep Space Observatory network, comprising multiple telescopes, monitors deep space activity. The Earth Legacy project culminates in the creation of extinction-level vaults within deep lunar lava tubes, safeguarding humanity's biological data and knowledge. These vaults store the genetic material of Earth's species and human DNA, along with digital knowledge, AI programs, culture, and history, ensuring that in the event of a catastrophe on Earth, the tools and knowledge for rebuilding are preserved on the Moon.